Hi, my name is Kazuki Itsuoka, and I'm from Ichikawa High School. And for the last oral presentation, I will be talking about my research about oscillating chemiluminescence reaction. And it is known that by adding luminol to the oscillating system using 4D substances, a sudden strong chemiluminescence can be seen repeatedly as the time flows. And we wanted to understand its mechanism. And we used a photoelectric tube to measure the chemiluminescence intensity, and we used a pH sensor and oxidation reduction potential electrode to measure the pH and ORP simultaneously when the reaction is going on. And these are the regions we use for the reaction. And as you can see, the mechanism of the reaction is so complicated, so we divided in 3 simple parts. So at the beginning of the reaction, a reaction forming this complex will start, and this complex will be accumulated in the solution. And at the same time, the SN negative ion will react with H2O2 and generates this radical. And when the concentration of this complex has crossed a threshold, oxidation of this complex will start, and this complex starts to react with this radical and generates 2 same radicals. And this radical will again react with this complex, so we call this reaction a feedback loop. And this reaction will go on and on until the complex are totally consumed, and then the feedback loop will stop, and it will return to the initial state. And the process will go on and on, so that's why. Then the radical will react with luminol, so that's why sudden strong chemiluminescence can be seen repeatedly in the solution. So to understand the mechanism more, we try changing the concentration of Cu2 plus and H2O2. And then first we measured the oscillation periods when we change the concentration. And as you can see, as the concentration of the Cu2 plus has increased, the oscillation period decreased. And the reason is that the reaction forming this complex is a rate-determining reaction, and as the concentration increases, and then the concentration of this complex will easily cross a threshold, so that's why the oscillation period has decreased. So next we measure the chemiluminescence intensity and plot on the graph. And as you can see, as the concentration increases, the intensity has decreased. And when the concentration increases, the oscillation period will decreases. So the gap between the strong chemiluminescence, this radical will be generated, but this radical won't be generated enough if the oscillation period is short. So that's why the chemiluminescence intensity has decreased. So next, we try changing the concentration of H2O2. And as you can see, as the concentration has increased, the oscillation period has decreased. And we can explain that by the same reason as I told last time about the Cu2+. And the next is the chemiluminescence intensity. And in this part, as the concentration increased, the chemiluminescence intensity has decreased. But in this part, as the concentration increases, the intensity also increased. So the reason is that the H2O2 are not only related to the reaction number 1, it is also related to the reaction number 2. And if the H2O2 aren't enough in the solution, that means that this radical won't be generated enough to react with luminol. And that's why the chemiluminescence intensity has decreased if the H2O2 are enough in the solution. So next, we study the effect of this radical in oscillating chemiluminescence reaction. And in the paper I referred, it says that this radical will cause a sudden strong chemiluminescence, but it didn't say anything about this radical, and it may affect with luminol. So I tried to see whether the luminol will react with this radical. And so we use these 3 regions to generate this radical, and we put luminol in the solution, and we see whether the luminol will emit the lights. And as a result, it didn't emit the lights, so which means that this radical is the substance that made luminol emit the lights. And we also tried 3 other chemiluminescent substances, and only LZ12 has reacted with this radical. And so next we try to use these three other chemiluminescent substances instead of luminol for the oscillating chemiluminescence reaction. And as you can see, this substance didn't emit light as much as luminol, and this substance, isoluminol, didn't emit the light at all, but when we use the L012 instead of luminol, between a sudden strong chemiluminescence, a gradual increase in chemiluminescence intensity was discovered, and which couldn't be found by using luminol. And if we compare the graph, it is obvious, the difference is obvious. And so what caused the gradual increase in chemiluminescence intensity? So first we focus on the fluctuation of ORP, and as you can see, when a sudden strong chemiluminescence was seen, the ORP has decreased at the same time. So we built the Nernst equation for this reaction, and when a sudden strong chemiluminescence can be seen, that means that the feedback loop is going on, so the concentration of Cu2 plus will increase by reaction M20, and the concentration of this radical will increase by M21. And the feedback loop is going on, the concentration of these two substances will decrease because it will be consumed. And for the pH, as you can see, when the reaction is going on, the pH are decreasing, so that means that the value of this part should increase. But ORP has decreased at that point, so it means that we made a hypothesis that maybe these radicals are substantially consumed at that time. So to prove that, we tried adding a radical scavenger to the chemiluminescence intensity are gradually increased. And so when the chemiluminescence intensity is gradually increasing, and when we add if we add the ascorbic acid at that point, which kills the HO2 radical, the chemiluminescence intensity should decrease. And as a result, when we add the ascorbic acid, the chemiluminescence intensity has decreased, so which means that this gradual increase may be caused by the generation of HO2 radical. And we also tried changing the concentration of H2O2 and as in a negative ion. And if this gradual increase is caused by the generation of HO2 radical, if we increase the concentration of these two substances, that means that the generation of this radical will also increase. So, and next we measured the gap between here, and we calculate the average and plot on the graph. And as you can see, when we change the concentration of these two substances, as the concentration increased, the chemiluminescence caused by this HO2 radical also increased. So this evidence proves that that gradual increase is caused by the generation of HO2 radical. And for the last research, we also studied the relation between the several chemiluminescent substances and the chemiluminescence intensity. And as you can see, the L012 absorbs a wider wavelength than isoluminol and luminol, and that is why that L012 has a phenyl group on its structure, which isoluminol and luminol doesn't have. So it makes the gap between the LUMO and HOMO to be short, and I think that's why this L012 will react with those radicals so easily. So in conclusion, in oscillating chemiluminescence reaction using L012, a gradual increase in chemiluminescence intensity within a sudden strong chemiluminescence was found, and which couldn't be able to discover by using luminol. And relationship of the fluctuation of ORP and chemiluminescence intensity and the addition of HO2 radical scavenger has led the chemiluminescence intensity within a sudden strong chemiluminescence to decrease, and when we increase the concentration of H2O2 and KSCN, the CR intensity within a sudden strong chemiluminescence has also increased. So these results prove that an increase of the concentration of HO2 radical within a sudden strong chemiluminescence is caused by that novel phenomenon. So these are the references, and thank you for listening.
ありがとうございました。 それでは質疑応答へと移らせていただきます。ご質問のある方、挙手をお願いいたします。はい、ではマイクをお持ちいたします。
Beginning of your talk, you added increase the concentration of hydrogen peroxide. You said that your rate determining step is become first. Reaction rate of rate determining step become first. So the period of fluorescence becomes shorter. You said, but rate determining step go first doesn't directly mean the period becomes shorter. Could you explain why rate determining reaction goes first? So after that, why period of fluorescence is shorter?
So let me explain. Just hold on a second. So as you can see at the beginning of the reaction, this CO2 plus will react with H2O2 and Sn negative ion to generate this complex, and this complex will be accumulated in the solution. So when we increase the concentration of H2O2, that means that the concentration of this CO2, this complex will easily increase. So, which means that the concentration of this radical, this complex, will cross a threshold easily. So that's why the oscillation period has decreased.
ありがとうございます。その他、はい、ではお願いいたします。
If you don't want, you don't have to answer to this question. Okay? Your English is pretty good, and particularly your scientific terms or chemical terms is very, very precise and very good. Where did you learn chemistry?
At school?
Which school?
Yeah.
Which school?
In my school. Yeah.
So
Ichikawa High
your
School.
teacher taught you that English?
Actually, those English I just search on the dictionary and just put in the word.
Well, I know, but it's the pronunciation is really
Okay.
things which you can't learn in the high school in Japan.
Okay. So actually, my mother is born in the overseas, and
But still, it's your chemical terms.
Chemical terms.
Is pretty good.
So
you must have learned that, say, any names of compounds or terms, physical terms, whatever. You must have learned it from something.
Well, I just went through the dictionary and the textbooks.
Okay, well, if so, that's okay. I mean, I have no further question.
Okay.
ありがとうございます。その他ご質問はございます。はい、では松坂先生お願いいたします。
So many results. So my simple request is, please distinguish what have already or previously known or proposed, and what are the original new findings in your research here.
Okay. So at first I say that I want to understand its mechanism, so I just change the concentration of the substances, and these are already researched as the last time. But what is new is that we used L012 instead of Luminol, and that is the new thing. And if we compare the graph, you will see that between a sudden strong chemiluminescence, when we used the L012, there was a gradual increase in chemiluminescence intensity. And we discovered this phenomenon, so we call this novel phenomenon. So, is it okay?
ありがとうございます。ではお時間も参りましたので以上とさせていただきます。市川学園市川高等学校の皆さんでした。ありがとうございました。